Okay, everybody must try this one question. Okay, if you never print out, never mind, just see the screen here. Okay, this one, topic 4.1 is quite easy. There's a thermal equilibrium. Thermal means heat. Equilibrium means balance. So that means I'm talking about balance heat. Okay, so from here, the first one, we go and see thermal equilibrium actually what's the meaning. So example, when a cool metal spoon, you see this one is a cool metal spoon. So I put into the cup of the hot coffee. Okay, later you see the spoon and the coffee are say thermal equilibrium. Okay, so that means thermal contact, not equilibrium first. Thermal contact means two things different temperature that I put together. We say thermal contact, heat contact. Okay, because the heat energy can be transferred between the two bodies, how can the metal spoon cool down the hot coffee? So this one is one of the question. So later you put the spoon, put in the coffee. Later you find your spoon become hot, become heat up. Okay, after some time you find the coffee become cool down. So this one is related to heat transfer. Okay, heat transfer normally better is a contact lah. If you both contact, the heat will transfer faster. So this one we call thermal contact. Okay, still not yet thermal equilibrium, contact first. So what is the final condition of the spoon and the coffee? Okay, sure the spoon will heat up, then the coffee sure cool down because the heat will lost to the surroundings. There also some heat absorbed by the spoon. Okay, so this one is a common sense. This one also daily life. Every time you drink the coffee, you drink any milk powder, you also know. This one is a situation we feel before. Okay, now we see an example. When a hot coffee, okay, and the metal spoon are in contact, okay, energy is transferred from the hot coffee, okay, to the metal spoon. After that, don't forget, metal spoon also got transfer energy, go to hot coffee, but very, very less. Okay, don't say, hot transfer to cool. Cool never transfer to hot. God, but very, very slow lah, a bit only. Okay, after the short while, okay, you find it. Metal spoon, the temperature, and hot coffee temperature is the same. Okay, then we can say, okay, example, this one is a 20 degrees Celsius. From the spoon, go to hot coffee. Then finally, hot coffee also 20 degrees Celsius. From the hot coffee, go to spoon. So you can see actually it's the opposite direction. So opposite direction, the net flow of the heat, how many joule? 0 joule. Okay, both also got transfer, but you transfer for me, I transfer for you, is the same value. So finally, the net flow is a 0. Okay, if I say heat transfer 0, this one wrong. You cannot say heat transfer 0. Heat still got transfer, not 0. Only you can say net heat flow 0. That one I understand, net already. Okay, so this one concept we call thermal equilibrium. Okay, when I'm just talking thermal equilibrium, you must bring two things. One, both same temperature. Okay, this is the first point. Second point, net heat flow equal 0. This one is the second point for the thermal equilibrium. Okay, so now we continue with the thermal equilibrium. Okay, the spoon and the hot coffee are in thermal contact. First must be contact. Okay, which means the heat is transferred between to each other. Okay, number 2, the temperature of the hotter object will decreases. Okay, means the hot coffee, slowly the temperature will drop. Okay, while the temperature of the cool object, your spoon, slowly they gain the temperature and they're up. Okay, until where? Until both same temperature. Okay, when both same temperature, we call this one situation is thermal equilibrium. Okay, understand? Thermal equilibrium is what meaning? It must be thermal contact first. Then you're talking about a hot object lah. Hot object, they will transfer the heat to the cool object. Then the cool object also will transfer the heat to the hot object. But sure, it's a hot object, transfer more lah. Okay, because hot object, the temperature is higher. They're faster to transfer more heat to come out first. Okay, after a while, you must say after a while, after some time lah. So the both temperature is almost the same already. So when it's just same already, then you say about the net heat flow. Now it's a zero. Okay, net heat flow is a zero. So we can say this one situation is what? Thermal equilibrium. Okay, so net heat flow zero, both objects same temperature. So these two things is a point for thermal equilibrium. So when the question asks, what means of thermal equilibrium? So these 2 points you need to write. Okay, now we go to explain thermal occur, how equilibrium. So this one's the first one, the hot object. When two objects must thermal contact. First must be thermal contact. Okay, heat transfer. The heat energy is transferred from the higher temperature to lower. Normally higher is bigger go to lower temperature, but the lower also a bit transfer to the hot object. Okay, finally you must say net heat flow zero. Then achieve same temperature. And we baru say thermal equilibrium. Okay, this one is one of the experiment. You can refer your textbook to show the thermal equilibrium between the two bodies. So from here they say they're using the two beaker. Okay, one thermometer they put inside the beaker A. Beaker A. This one's a beaker B. Okay, beaker B is a hot water. Okay, this one's a tap water. So tap water is a cool one. Okay, this one's a hot one. So that means when starting, when you just put in, you find this one temperature is a lower. This one temperature show higher lah. Okay, you need to wait. This one we call thermal contact already. Okay, after you wait some time, this one will start to drop. Okay, because they transfer the heat. Hot object transfer the heat to the cool object. This one they gain the heat. Gain the heat, they up already. Okay, until both level is the same. Until the both level is the same, that means the temperature becomes same. Then we call you to achieve thermal equilibrium. Okay, then the net heat flow zero. Okay, so this one is a one experiment. They want to prove what means of the thermal equilibrium. Okay, one of the questions they also will ask, why wrapping? The whole beaker, they go to wrap by using the tissue paper. Okay, so the reason is prevent heat loss. Prevent the heat loss lah. I want to more accurate a bit, so I prevent the heat loss. So they say the fill 40 ml of the 50 degrees Celsius hot water inside the beaker B lah. Okay, A only using the normal tap water. So place the beaker B into the A. After that, place the thermometer A and also B. Okay, recording the reading of the A and also B for every 30 seconds. So you need to check until what time the temperature becomes the same. Okay, so from here when starting, they find it. B is a 60, then the tap water is 28 only. Okay, after that, 30 seconds, check. This one up already. Up already. This one drop already. Okay, they transfer the heat. Okay, after until 60, I find it. Both is exactly the same. So I say this one, they say thermal equilibrium achieve. Okay, thermal equilibrium achieve. Okay, why is the beaker A wrapped? This one is one of the questions they will ask. Why they need to wrap it? So the reason is prevent the heat loss to the surrounding. Okay, describe the changes of the temperature of the hot water and tap water. Hot water will drop. Okay, temperature will drop. This one will be increase. So we just answer temperature of the hot water slowly decreases. How about the another one? The temperature of the tap water slowly increase. Until when? Until both temperature same value. Okay, what causes the changes in the temperature? Okay, what causes? So the answer is exchange heat flow. Why the temperature will up and down? Because of the heat. Heat start to flow normally from the hot to the cool. So from here, the hot water flow to the cool water. So finally, the temperature changes. Okay, temperature is a final one. Okay, let you to see one. The heat transfer, you cannot see one. So you're using the thermometer to prove the temperature, how many, then you baru say hot water transfer the heat to the cool water. Because the heat, there's a, we cannot see, there's an abstract one. Okay, we cannot see what happened. We only can using the thermometer to represent the heat transfer. Okay, so this one is maybe the process question. They just ask you, okay, 4 marks. Please explain how to achieve thermal equilibrium. So that means you need to explain point by point. Okay, normally we start must thermal contact. 2 object must thermal contact. Number 2, you must talking about a hot object will transfer bigger part the heat to the cool object. Then the cool object also got transfer to hot one, but only small part. Okay, after that, you must say after some time. After some time, both readings, temperature become equal. Hot object will drop lah, then the cool object will gain. After the temperature until same. Then we can say, now the situation is a thermal equilibrium. Then the last one, you add one more sentence, net heat flow is 0. That one is how to explain the situation by using concept thermal equilibrium. Okay, so the first one I'm going to explain. Hot object P, thermal contact with the Q. So the rate of the heat transfer, P to Q is higher. P to Q sure higher lah, because the hot object transfer more heat to the cool object. Okay, compared to the Q transfer to P. Q also got go to P, but you see the arrow, smaller one. Okay, now another situation. Okay, there is a net transfer of the heat from the P to Q. Okay, so that means net. Slowly, the arrow becomes same size, because the net ready. So therefore, the temperature P, okay, will drop. Okay, temperature Q will increase it. Okay, so until situation is a thermal equilibrium. So you see this one, from the 100 drop until 70 something. So this one's from the 20 something up already, become 40. So finally, both should be the same. Okay, so this one we call it thermal equilibrium. Both arrow, the size same already, but the heat still transfer. You cannot say, oh, now is no heat transfer. God, the heat is transfer. Maybe this one 30 joule, this one also 30 joule, left, right. So finally become same. So from here, I can make a conclusion. Temperature P and temperature Q become the same. Okay, rate of heat transfer, P to Q also same. Rate heat transfer, me, 1 second, I transfer 30 joule for you. Okay, another 1 second, you also transfer 30 joule to me. So we call it same. Rate of the heat transfer, P to Q or Q to P should be the same. Okay, last one, net heat flow, PQ becomes 0. This one we call thermal equilibrium. Okay, I mentioned so many times, only the 2 points. Temperature is the same. And the last one, net heat flow equals 0, then thermal equilibrium. So only 3 points together one. Okay, so this one's a diagram, thermal equilibrium, how to achieve. Okay, contact first, then the temperature start up and drop, finally become the same. Okay, thermal equilibrium in your daily life, we apply. First one, thermal equilibrium causes 2 objects in thermal contact to reach the same temperature. Okay, example, heating. Heating object, hot air in the oven, thermal contact with your cup of the cake. Okay, heat from the hot air in the oven flow to the cupcake. Okay, hot transfer to the cool. So this causes the cupcake to be heat up. Until when? Until both temperature is the same. Thermal equilibrium achieved. So when the thermal equilibrium achieved, so that means your cake already baked finished. So you can eat already. So that means heat transfer from the oven go to the cooler object. Your cooler object now is a cupcake. Okay, until certain time, both temperature is the same already. So that means your cupcake already cooked, finished to cook. The temperature, oven, and your cupcake is exactly the same. Okay, if you say the cupcake got transfer heat to the oven or not, we can say very, very small because the oven, the temperature very high. Your cupcake is very, very small only. So that means transfer a bit lah. Important is oven transfer to the cupcake. Okay, number 2 also is transferring from the clinical thermometer. If you place under the tongue of the patient, so what transfer first? The heat from your body transfer to the thermometer. So you just wait. Okay, after some time you find it, both temperature become same already. So your body temperature now can using the thermometer to represent when they achieve thermal equilibrium. So now you can take out the thermometer. Now you go to read the reading. That one, the reading is exactly your body temperature. Okay, so this one we're using the thermal equilibrium in our daily life. Okay, when you're heating, cooling also can. Okay, you see your refrigerator. When the food you keep inside the refrigerator, your food is a normal. We cannot put the food is very hot. You put inside the refrigerator. Normally, it's a let the food cool down first. Okay, but not cool as a refrigerator lah. Normal temperature, room temperature. After that, you put in. When you put in, that means your food is a little bit high temperature compared to the refrigerator. So the heat must transfer from the food first. Your food is a high temperature compared to the refrigerator. So the heat will from the food flow the air into the refrigerator. So the refrigerator behind is very hot one. They release the heat go behind. So until thermal equilibrium. So until thermal equilibrium, what happened? Then your food become cool down already. I mean your food in the refrigerator, same like the temperature of the fridge. So you put at the fridge lah. So that means when starting your food is maybe 20 degrees Celsius. After that you put in. Okay, after some time, oh, you find it cool down already. Exactly same like the temperature of the refrigerator. So from here, the temperature of the food will drop and the food stay fresh. Okay, longer time. Then you will ask, if the food drop temperature, is it the refrigerator gain the temperature? Actually, yes. But they got fan, they got motor. So finally, you see the refrigerator behind, they release the heat, go behind. Okay, you find the behind part is very hot one because they want to release the heat. They want to make sure the heat from the food all take out. Okay, until the whole fridge is a cool one. Okay, another one is this one, the ice. Normally you drink the juice, you put the ice. So drink are cool down by adding the several ice. So your ice cube, you put in the drink. So how to transfer? The ice cube is a cool then the heat, the drink is a normal temperature. Okay, normal temperature. So that means when you just put in, okay, they start to cool down. Okay, they start to transfer the heat to your drink. So normally now it's a cool is more than the heat because our drink is not hot drinks. If hot drink faster lah, but this one normal drink, so the ice cube will transfer the heat. How to make the ice cube transfer the heat? So the ice cube must melt. They must melt. Okay? When they just melt, actually what's happened? They absorb the heat. Baru can melt. Okay, they absorb the heat from the surrounding, then your ice start to melt. Okay, if they already absorb the ice, absorb the air from the surrounding, what happened for the surrounding? The surrounding become cool down already lah. Okay, surrounding already cool. Near the glass here, cool already because the heat already absorbed by the ice. So finally you find it, the ice already melt, then the drink cool down. Okay, the drink cool down because surrounding already cool. The heat already absorbed by the ice. Then the ice already melt. So your drink keep cooling. So from here they say, drink are cool by adding the several ice cube. Ice cube absorb heat from the drink also, from the surrounding also, finally melt. So the melt ice cube absorb the heat from the drink. So now the drink cool down already because the heat already absorbed by the ice. So finally, I find it, the thermal equilibrium achieved, drink, and also the ice, the temperature is exactly the same. Okay, finally, your drink become cool down but your drink cannot become 0 degrees Celsius because your ice start to melt already, unless the whole ice and also water liquid inside the freeze. Then both also 0 degrees Celsius. Okay, but now no, your water still liquid, your ice is a solid. So maybe your ice gain a bit temperature up already, 2 degrees Celsius. Then your water also drop, become 2 degrees Celsius, like this. Okay, so this one is called thermal equilibrium. If you want both also 0, then you must put inside the freezer. Okay, but now no, your ice, they will drop temperature, and your liquid, they will up a bit temperature. Sorry, terbalik. Your ice will be melt, increase temperature. Your drink drop temperature. Okay, so finally your ice, the juice become cool down. Okay, become cool down. Then after that, the ice will slowly to melt because they absorb the heat from the drinks. Okay, so this is a daily apply for the thermal equilibrium, can heating and also can cooling. Okay, this is the last part for today. Calibrate the liquid in the glass thermometer. Okay, so we need to find out example, one thermometer. Okay, no calibration. They never tell you where is 100, where is a 0. They don't tell you, but you need to find out. So this one we call calibrate the liquid in the glass thermometer. Normally we're using mercury Okay, mercury. A thermometer that does not have the scale, no scale, okay, can be calibrated using the 2 fixed temperature point. Okay, we only can using 2 fixed temperature point for the liquid, that's the water. Okay, we're using the water as a standard calculation because we know water is a 0, then become freeze. Then when become boiling steam, there's a 100. Okay, this was a normal common sense for the water. If you ask me about the oil, I don't know. If you ask me mercury, I also don't know. So that's why they're using the water as a standard form to find out where is the melting point, where is the boiling point. So if I'm talking about melting point, that means the ice to melt. That one is a lower fixed point. If I say boiling point, there's 100. There's an upper fixed point. So how to get it? The process of the calibrating using the thermometry properties. Okay, you need to remember this word. Thermometry properties of the liquid in the glass. So thermometry means what? Physical properties can be measured, such as length, coulomb of liquid. So the thermometer, actually, when you see the thermometer, which one tell you the reading? Sure, it's a mercury tell you the reading. What mercury? Volume of the mercury. Then they tell you the reading. If the mercury never move, you also don't know what's the reading. So from here, thermometry properties for thermometer, the answer is what? Volume of mercury. So when you see this, what thermometry property means, what led you to understanding the measurement? So not only for thermometer, maybe got another situation, pressure. Pressure also can. How you know the pressure? How many? I read the pressure reading, so I know the needle when it deflected, I know. Ammeter. What's the thermometer property for the ammeter? Current, the current led the needle to deflected. Then I know what is the reading. So this one is called thermometry properties. Okay, later I show you more about that. This one just for the thermometer normally we use. Either alcohol, either is mercury. Okay, this one is one of the experiment. They want to find out where is the boiling point, where is the melting point. So This all thing you can refer your textbook. Important is this part. Okay, I want to find the melting point. I must put the thermometer inside the ice cube. Okay, I want to make it drop until 0. Then I go to measure. Here is how many cm. Okay, I put inside the the water. After that, got heater one. Heat until 100 degrees Celsius. Then I go to see what is the length. Okay, using the length to calibrate your thermometer. Okay, so after that, this one. When 0, this one is 100. 0, that means you count from here. This one is how many length. 100 is how many length. Okay, when I got 2 fixed point already, now you take your thermometer, put to in another liquid. So another liquid may be up until here. So this one we call L data. L data, they will ask you, how many degrees Celsius? Then you need to find. So this one normally using ratio to find. Okay, when I just show you, then you understand already. Okay, conclusion, like this. Okay, when 0, what is the line? When 100, what is the line? Okay, then they put another liquid, put in. Then they label this one as a L data. Then they ask you, L data, what is the temperature? So from here, remember, 0 until 100, they got 100 similar part. That means you need to separate the part lah. Part by part got 100. So if you get here is a 20 cm, then your 20 cm need to divide by 100 lor. Then after that, you need to do the calculation for ratio. Okay, the formula is here. L data minus L0. L100 minus L0. Multiply 100 degrees Celsius. Because from the 0 to 100, only 100 degrees Celsius. So we multiply with the 100 lah. So we get how many temperature. Okay, so this one only using the ratio do a calculation. So I just want you to answer one question before you leave. Okay, and try this question. Okay, let's see here. Okay, when I get 100 degrees Celsius, I find it the length is a 15.6. Okay, then 0 degrees Celsius, nothing, exactly the 0. So now they put in one of the liquid, don't know how many degrees Celsius, but there's a 8.5 cm. So I want you to give me answer. Data is berapa? Okay, so this one answer we ask Enchi. Okay, Enchi using this formula to count for me. Data is how many?
Okay, teacher.
Okay, we just put in only. Data is it? 15.6 minus 0 lah. 100. Sorry, terbalik. Data is 8.5. 8.5. Right, 8.5 minus 0. 15.6 minus 8 minus 0. Multiply 100. Okay, Anshi, answer?
54.48, yeah.
Okay, must write degrees Celsius. So I show, okay, like this only. And the final answer, 54 point. Normally put 1 decimal point lah for the degrees Celsius. You know, we cannot read more decimal point. So 54.5 degrees Celsius. Okay, just one formula only for this one topic. Then the rest, okay. Nothing already. Then after that, you need to learn about the thermometer lah. Why we need to using mercury. Then after that, some is related for the essay, characteristic for the thermometer. And formula only one for thermal equilibrium. Okay, any question you want to ask? Anyone? Tongzhen answer. Example 3. Okay, I want Tongzhen to answer the question.
Answer is 42.5. 42.86.
Okay, we're going to check. Okay, this one is an info. Actually, the L0 is a 0 because behind they never show anything. They never show anything. Okay, so this one L15 is when I just put in one of the liquid, don't know what is the liquid lah. So I get 15 cm. So L, the stem, the steam point, not 20. The steam point is a 20 plus 15. Okay, 35. So then I'm using the formula. L data is a 15 minus 0. Then the L 135 minus 0 multiply 100 degrees Celsius. So there's a 42.9x6 lah. Okay, normally 42.9 degrees Celsius. Okay. Okay, I think that's easier for you. You can answer all the example question already. Okay, only one formula you can apply all. Then some is about the concept lah. If you understand, then you do first. Okay, if no problem, so we just end from this part. Okay, so thank you everyone. See you from the next Friday again. Bye.
Thank you, teacher.
Okay, good
teacher.
night.